Alright, the last special segment for the first day of notes is the perpendicular bisector. The definition states that a perpendicular bisector is either a segment, ray, or line that is both perpendicular and a bisector. Very clever name. So it's perpendicular to one side of a triangle, and it's perpendicular at the midpoint of that side of the triangle. So example up here would be if this point is my midpoint, any segment, ray, or line that cuts straight through that midpoint and is perpendicular. I could technically have three perpendicular bisectors, because if I went here and found the midpoint and had a segment, ray, or line perpendicular, I would have a perpendicular bisector there, and I could do the same thing on this third side. If I had a point that was a midpoint and a line, ray, or segment that cut through it, perpendicular, it would be a perpendicular bisector. Key things of a perpendicular bisector. First off, what does it not do? It does not necessarily go through the vertex of a triangle. Notice all three of these actually intersect two sides of my triangle. The one that's important is this one that's perpendicular, but then it crosses at a side, not at a vertex. Same thing with this one. Perpendicular, crosses my side but not at a vertex. Perpendicular, side but not a vertex. And we already talked, every triangle has the or three perpendicular bisectors like we drew up here. And the next key point is that every point that is on the perpendicular bisector is equidistant to the endpoints of the segment being bisected. What does that mean? Well, here's exactly what that means. If I take a look up at our original drawing and I focus only on my first perpendicular bisector that we drew, what this means is that every point that is on that line that we drew here, say for example this point, it's just a random point on that line, it is the same distance to the endpoints of the segment that is cut in half. This is the segment cut in half here. This point, if I were to connect the endpoints here and here, those new lines I just drew are congruent. That's what equidistant to the endpoints mean. And that's true no matter where I put that point. I could put a point up here. It's still on my perpendicular bisector. This segment is going to be congruent to this segment connecting my endpoints. That works if I go below my triangle. So I don't have to be in or above my triangle. I could even be below. This segment here is congruent to this segment here, connecting the endpoints. So let's see how that applies. If I am given that segment AB is a perpendicular bisector of triangle ARC, I know these segments are congruent because B is a midpoint. I know these segments are congruent because A is on the perpendicular bisector. I know that this is a right angle because it is perpendicular. So, first, find the value of x. Well, I really have three different equations I could set up. I could set 3y equal to 24 minus 9y. Well, that's not going to help me find x. I could set 5x plus z equal to 90 because it's my angle and it's perpendicular, but I don't know z. I can set 2x plus 9 equal to 9x minus 12. That's the one that's going to help me with x because that is the only variable in those two expressions. So 9x minus 12 equals 2x plus 9. This becomes an algebra problem. Subtract 2x from both sides, add 12 to both sides. x equals 3. Solving for y, we already talked about. I know that b is a midpoint, so I can set 3y equal to 24 minus 9y. Add 9y to both sides, divide, and y equals 2. And then my third equation that I was able to use is that 5x plus z equals 90. But I know that x is 3, so I'm going to go in here and get rid of x and substitute in 3. Now 15 plus z equals 90, subtract 15 from both sides, and z equals 75. So the key to a problem like this isn't the algebra, even though we need to know how to do it. It's what can I set equal over here, or what's equal to 90? And then recognizing that a perpendicular bisector, my point on it is equidistant, it meets at a midpoint, and it forms 90-degree angles. Tomorrow's videos will discuss 3 new special segments.